the heat, I'll tell you when to start filming. I mean, you can film, but just, you'll have to fast forward when you show your buddies, so they won't hear me talk. But the thing is that the, the sodium being in a test tube, it's, it still does the reaction, the heat. What we saw, we only did this like 2 times. That's why I'm, a little, well, that's why I want to make sure I use this fume hood, is the fact that the flame, you should be able to see the flame right around in here. It really won't burn down here because there's not that much oxygen, okay? So the sodium, when I drop it in there, bubble fizz, and I'm hoping to see some flame right above there, okay? So that's, that's basically it. How about you be quiet? You don't know what's going on here. You didn't even see me almost kill us last week. All right. This here, I never used this little butter knife thing.
Silver.
It's sodium. All right, how many valence electrons does sodium have?
1.
1 single valence electron. What group number is it in?
1.
Not just a coincidence, okay? So this is sodium going in, first try. I put it in this one. So
Fizz smoke and blow up.
No.
Fire.
Again.
Right now.
I know. What do you do?
Think about lighting the gas above. If it doesn't, I should be able to light it. It did burn by itself. That one has a little bit of water in it.
Whoa.
Okay, that's, oh, now you can see a little bit of flame in there. Obviously there's enough oxygen down at that low of a place. So it burned a little bit. Okay, that's hydrogen. Okay, and that's where the, builds up. Obviously it didn't, burn to the top like I saw the, and that's what makes this unpredictable. So, in terms of the, whoa, did you see that one? Okay. Somebody answer it and say Mr. Roney's room, please.
Next one.
All right, next one. Now, difference between this one, okay, this one had, well, it had more water. This one just has a little bit. Yep, Hannah.
So it's gonna work better.
Mr. Roney, I like your tie.
Oh, it went horribly wrong. Oh, that's just death. All right.
Matthew, Mr. Roney just got in my frame. Really?
Okay, let's go. Well, if it's got moisture in it, it will. All right, so this is less amount, probably in a smaller piece, but when you use less water, it just seems like you get.
Is this also sodium? Is this also sodium?
This is sodium as well, yes. Whoa! Oh. All right, that's got, see, there we go.
Whoa!
Still.
Whoa!
That's cool.
I don't care who you are, that was kind of cool.
That had a lot of less water than the other test tube.
Next thing.
That was the best one.
Okay.
That was a lot less water than the other test
anything
tube.
that I did after school testing it myself.
Why can't you push like a little bit bigger piece there?
I tell you, when I used bigger pieces, it really didn't seem to, it actually didn't seem to work as well. But that's what makes it unpredictable. And that's a use small piece,
That one has less water than that one.
But, you never know. And then you use a small piece again, it blows up. So that's part of the unpredictability. All right. Okay, this next thing. Okay. This is magnesium ribbon. Okay. Now, magnesium is a, it's a metal. Okay, but when it burns insanely bright. Okay, like welding torch bright. All right. So the thing about it is, I'm going to tell you, you're going to, when you see it, it's going to temporarily have like, looks like somebody takes a picture of a flash, you blink your eyes. In fact, if you look at these lights, they maybe look, I don't guess they're that bright. But the thing is about the magnesium is that it's going to burn incredibly bright, but not for very long, okay? Now, the thing is that it doesn't look very silvery because it's oxidized a little bit, which just simply means it's combined with oxygen. However, when I light it, as reactive as it is, it takes energy to get it going. And unfortunately, I don't have longer tweezers than this, but, for the sake of demonstration and things, I'm going to try and get this out of the way. By the way, if we were to record the temperature of the water, definitely would be warmer. Okay, so this is, I tell you what.
That one had less water than that.
Oh, yay.
Yeah, it's dark now.
All right, let's see, turn that light out for me, please. Let's switch now. Flips.
Okay, here we
go.
go.
So this is magnesium. And like I say, it'll take a second to get it going.
Oh my God, my eyes.
It's that bamboo. All right, and it's not that it's going to hurt anything. It just won't burn as well because oxygen can't get to it. All right, I'll get one more piece. I'll try to do a better job of holding on to it.
Burn the whole thing.
Yeah. Oh my God. Okay, if I were to, have this in there, and let's say a flame dropped into this, run. Okay, and it's not that it would blow up, but it would get dangerously hot, and that would be something that, well,
that's what I did.
that would be bad.
Probably.
So I got tweezers. What do I do with my tweezers? I had black tweezers, and they disappeared.
Right there.
Where? Oh, sorry, see him. Okay, thank you.
And the next camera is a huge shield because I'm more important.
Okay. No. Yeah, thanks. Alright, so magnesium, group 2, 2 valence electrons, reactive, but not nearly as reactive as sodium, obviously. That's shaking, that's pre-Parkinson's and coffee.
Oh, I can't see through my camera.
Okay, I'm moving it around so it doesn't burn on the same place, your retina. Okay, now look up to the ceiling, blink a couple times.
Ah, it's black.
Okay, it kind of
I
has
see
like
nothing.
well, sometimes they're called tracers.
I see tracer.
You mean like a tracer bullet?
Alright,
Like X's?
I literally see